Section 1.3, Radicals and Rational Exponents. In this section, we will evaluate square roots, use the product rule to simplify square roots, use the quotient rule to simplify square roots, add and subtract square roots, and rationalize denominators, and use rational roots. This is part 1 video. Simplify the square root below. In order to simplify a square root, you are looking for perfect squares, one of its factors to be a perfect square. So 2 squared, 3 squared, 4 squared, 5. So this is 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225 and 256. So that's up to 15 squared. Now, one of these numbers has to be a factor of that in order to simplify. Okay, so looking at this is square root of 180. So I know that I could get square root of 9 times the square root of 20. Right? Now your calculator may simplify that for you, and that's fine, but you need to understand how to simplify square roots, that one of its factors in order to simplify must be a perfect square. So the square root of 9 comes down to 3. Now I'm going to split square root of 20 because 4 go. All right? So that's square root of 4 times square root of 5. And then that's 3 times 2 times the square root of 5, which gives me 6 square roots of 5. So that's what the square root of 180 simplifies down to. I always, when I start with a problem, I'll check 4, 9, 16, 25, 36, 49, 64, and so forth. Once I get up to over half of the number, then I know I'm done. So, and a majority of these, within that is 80% of the factors that will reduce a perfect or will become a factor of a radical that's square root. 80% of it's one of those numbers right there. So you don't have to check too much. All right. So in order to multiply, it's inside to inside and outside to outside. So these are the insides, okay? And the outsides would be the coefficients that are setting there. So you kind of treat the radicals kind of like variables. Okay, so 1 times 1 is 1. I'm just going to put that. Now, you typically do not simplify these radicals before you multiply them. So that is going to give me 7 times 14 would be the square root of 98. Right? So everything underneath the radical gets multiplied together. Now I'm just going to ask, okay, will 4 go into it? No. 9, no. 16, no. 25, 36, 49. 49 will. Square root of 49 times the square root of 2. And this simplifies down to 7. And of course 2, square root of 2, I can't simplify it because the number that I'm starting with, 4, is above it. So that goes down to just 7 square roots of 2. Okay. Now, in order to add or subtract, you must have common radicals. And you can see that I have a square root of 3 here and a square root of 48 there. Now, if it's good to check each one. I can't simplify the square root of 3 because the number I normally start with is 4, seeing if it's a factor, right? Because 4 is a perfect square. And 3 is below 4, so I know that 3 cannot be simplified. So I know that I've got to get a square root of 3 out of here in order to be able to add these. So 48 divided by square root of 3, well, that gives me square root of 16, and you should see that 16 is a perfect square. So square root of 48 simplifies down into 4 square roots of 3, and now we have 3 square root of 3's, and since these are the same, we just add 4 and 3, and we get 7 square roots of 3. So that happens on addition and subtraction. You must have common radicals. simplified. Okay. Now let's look at this one. This one is a cube root, so it's a little bit different. On square roots, we were looking at perfect squares. On cube roots, we'll be looking for perfect cubes. Okay, so what you have to understand is um, what are some perfect cubes, right? So 2 cubed is 8, 3 cubed is 27, 4 cubed, let's see, that's 64, 5 cubed is 125, and that should be, you can go on up, okay? Um, now, I've got to see if one of these is a factor of that. And of course, you can go on up to about 11 or 12 if you need to, right? Um, so what you end up finding out is the cube root of 1331 and the cube root of 2. All right, cube root of 2. Now 1331 just happens to be 11. Well, let's get this back. 11 cubed is 1331. Okay, so you need to just create a list of perfect cubes all the way up to 11, 12, 13, because some of these numbers will be big, and you can't do those on a calculator. Okay, so this simplifies down into 11, and of course I've got a cube root of 2, and I'm starting out at 8, and 2 is below 8, so I am good. So that is how you simplify a cube root. One of its factors must be a perfect cube. So you want to continue this, okay, all the way up to 11. All right. Now, um, that's 343. So let's look at this one. Simplify the following expression, write as a reduced fraction. Well, what you should identify is I need to look at my perfect cubes list, and you should see that this one and that one are perfect cubes. The cube root of 125, well, ladies and gentlemen, that is just 5. And the cube root of 343 is nothing more than 7. So that simplifies down to 5/7. Okay. So sometimes they'll give you perfect cubes like that. All right, let's do one more. And you know what? Let's don't do one more. Um, let's stop right here with part 1. Let's let this be the end for part 1. Okay, so get this back up, and I'm going to stop.